Hi guys, welcome back. Today we're doing longest palindrome. So we're given a string S which consists of lowercase or uppercase letters, and they want us to return the length of the longest palindrome that can be built with those letters. So they tell us that letters are case sensitive. So for example, capital A and lowercase a is not considered a palindrome. And if we take a look at the examples, in example 1 we're given this input string S which equals this, and then we would output 7 because the longest palindrome that can be built is this, which the length of that is 7. So if we look at this, so like it doesn't really matter like if this string itself is a palindrome, it's just if we can make a palindrome from the letters that are in here. So we can rearrange them and that's totally fine. So in example 2, we are given this input string S which equals just A, and then we would output 1 because the longest palindrome that can be built is just A whose length is 1. So in this one, I'm thinking because the order doesn't matter here, we just care about the frequencies. So like we want to be able to iterate through the string or the characters in the string and count up how many of each one we have, because that way we can tell like if we can create a palindrome from it or not, right? Because like if like, so let's just say like make it super simple, right? We just have like, let's just say we only have D and like D, right? So like for D, then we have 2 of these. So we know that this can be used in a palindrome. Right, so like, I don't think I'm explaining it very well. So like, if we have one single letter, right, like for example A, then that's a palindrome because it's by itself. But like, let's say we have A, B, right? Then this still works actually because we have like the 2 B's can be like in the beginning and the end, right? So then we can put the A in between, and then this is still a palindrome, so this works. But if we just have A, B like this, then we can only use one of these letters for the palindrome because the other one is going to like break the palindrome requirements, right? So like for every like we can have one letter by itself in the middle of a palindrome like this, but that's it. Everything else it's going to need to be matched up from inside to out, if that makes sense. Like from front, or like front and back needs to be matched up. So like if we have like, let's say we have another one, so like A, B, C, right, like this, then we could put like 2 C's, 1 B, and an A, and then go like this, right? And so this would be a palindrome. So this is how we could rearrange it to be a palindrome, and then we would just like count up the length of this and return that. So let's just like stick another letter in here that we don't need. So like, let's say we have another D. Well, then we can go through here. We basically like, we're not actually going to construct the string, but we just want to count up how many of each letter we have so that we can see what we would be able to do if we were actually doing that, if that makes sense. So like if we go through here, we have 1 A. Okay, that's fine. Then we have 2 B's. So we know that we can use both of these B's because there's 2 of them, right? So like this A, maybe we'll just hold on to this and not count it yet because we might have another letter that or character that's like by itself too, right? So like we can only use like one of them. So like we'll just hold on to the A, and then we go through, so we have 2 B's, so we can use both of the B's, so we can add that to our length of our longest palindrome. Then we count, we have 4 C's, right? So we can use all 4 C's. But like, let's say we only had 3 C's, then we would only be able to use 2 of these C's, and then we would just hold on to the other one in case we have, right? In case we need like an extra letter at the end that we can add on, like in the middle like this or something, right? But like, otherwise, like, yeah, so if there's 4 C's, we can use all 4 C's, so we can add that on to our length. And then our D, like there's only 1 D, so like we can only use either that or the A. It doesn't matter which one because we don't care what the palindrome is, we just care about the length. So we'll just throw one of those in, and then that's the length that we'll return, which would be 2, 3, 4, 5, 6, 7, right? So that's basically how we're going to do it. And then we're going to want to use a hash map to count the frequencies of each of the characters. So I'll just put this example here so we can kind of follow along as we do it. And let's put the indices as well. I don't know if we'll need it, but you know, just in case. Okay, so we'll say map, and then we'll map characters to integers, because this is going to be the character to frequency. Okay, and then we'll Okay, right now it's empty, right? So then we're going to want to populate our map. So we'll loop through the string. So for I 0, I is less than s dot length, I plus plus. And then we'll just assign a char c to s dot char at I. That way we don't have to keep calling char at. And then we're going to want to put this into our map with the frequency. So like first of all, we'll add the key to it. So map.put c. And then, so if we don't already have c in here, then we're going to want to add this key with a 0. And then if not, well, either way, actually, we're going to increment it. But if we don't already have it, we'll want to add it first with a frequency of 0. So map.get or default c, comma 0 plus 1. So that's going to do that for us. So if we are looping through s, then our first character is a, and we do not have an a in here. So like, so as we loop through, right, so c is a right now, then we'll put a in the map, and we did not have the key a so far, so we'll add it with a 0. So that's what this is what it's going to look like. So it's going to be 0, but then we're going to add 1 to it. So then this is going to become a 1. And then the next iteration, then we are at b, and then we don't have a b, so we're going to add b, and then it's going to have the same thing. So it'll start at 0, but then we'll increment it, so it'll be 1. And then c, and then I'm sure you get the idea. So I'm just going to go ahead and add them all. So c will be 4, and then d will be 2. Okay, so now our map is populated. Now we want to loop through the map. So we're going to have some sort of loop here, and then we're going to want to count up the, because remember, as we're going through our string, we don't actually care what the characters are. We only really care about their counts, because like we want to know, first of all, if it's even, then we can actually use all of them in our length that we're returning. If it's not even, then we'll be able to use, like, if it's not 1, so like if it's anything but 1, then we can use all of them except for 1 for sure. And then if it's 1, or if it's like odd, then that last extra one, we'll only want to take one of those at the very end to stick in the middle, right? Like when we have an extra spot in the middle that we can use it, if that makes sense. So we're going to, like, because we don't care about, since we don't care about the frequency, since we don't care about the character, we're just going to loop through the frequencies. So we'll just say for int count, and then we'll just loop through the values of the map. So map.values. And then as we go through, so we're actually going to need 2 variables. So we'll one of them will just keep track of the length of our longest current palindrome, which will start at 0, and then we'll increment it as we loop through the frequencies of the map. The other one, we can keep a Boolean, so to check if we have an odd frequency as we loop through. So we'll say odd, and then we'll start it out as false. So if it's false, that means that every single frequency in here is even. If it's true, that means we have at least one frequency in here that is odd. So if basically after we are done looping through all of our values, if we have odd is true, then we'll add that extra, like we'll add one of the extra characters onto our length, if that makes sense. Okay, so first of all, when we are looping through our map's values, we are going to want to add the number of characters that we can actually use onto our length. So we'll say length plus equals, and then here's how we're going to do this. So I know this is going to sound really weird, but we'll do count divided by 2 and then times 2. And the reason I do this is so, like, for example, let's say our count is 2, right? So like let's say we are looking at character D right now. Well, since we have 2, right, 2 divided by 2 is 1, and then 1 times 2 is 2. So we can add 2 characters onto our length, right? Let's say, okay, count is 1, right? If count is 1, so like let's say we're looking at character A, then we can only, then we can't add anything, right? Because it's odd. So like this basically just helps us take care of the odd numbers, because like 1 divided by 2 is going to be 0. 0 times 2 is 0. So we can't add anything onto length, which is accurate to actually what we want. So like if we say count is 5, right, then we can actually take 4 of these characters. We just don't know if we can take the last one yet, so we're not going to add that yet until like the very end, depending on if odd is true, right? Which we will also keep track of in a minute here, so we can actually just, actually I'll just do that in a minute, but, so if count is 5, then 5 divided by 2 gives us 2, and then 2 times 2 is 4. So then we can add 4 onto our length, which is exactly what we want. So that's basically how this is going to work. Okay, and then now I'll take care of the other thing, which is keeping track of if we have any odd frequencies or not. So we'll just check if the current count is odd. So if count mod 2 is not equal to 0, then that means it must be odd. So odd will be set to true. Okay, and then we're going to do this for every single value in our map. And then once we've done that, then we just want to check. So if odd was true, then we can add another, like we can increment length one more time. So let's go ahead and do that. So if odd, then length plus plus. And then we can just go ahead and return our length, and that should be it. All right, so our time complexity, if we take a look here at what we are doing, so we have a loop here, which loops through the input string. So it's looping through every single character that's in the input string. So if we can call this O of n, where n is the number of characters in our string. We have another loop here, which is looping through all of our map's values, and this is also proportional to n, where n is the length of the input string, and that is because worst case, if every single character is unique, then our map could store exactly n characters, each with a frequency of 1. So that's also going to be O of n, and then those are our only 2 loops. So O of n plus O of n is going to give us O of n, where n is length of input string s. And then now for our space complexity, so our only data structure in here is our hash map. And from talking about the time complexity, we just discovered that worst case it could store every single character. So this is also going to be O of n, where n is the same thing. So yeah, that's it for this problem. Thank you guys for watching, and I'll see you guys next time. Bye!